All right, we're taking a look at number 18 here. So let's go through all the things that we need to find to graph these, okay? So by getting the domain, we have to set the denominator equal to 0. So we'll just square root to get rid of the squared. So really, it just amounts to setting the x minus 7 equal to 0. But when we add that 7 over to the other side, then we get x cannot be 7. Okay, so we'll open up at 7, but everything to the left is okay, and everything to the right is okay. Remember, 7's not allowed because if you plug a 7 in, 7 minus 7 will get you 0, and 0 squared will get you 0. So you have a 0 in the denominator. So we're opening it up and saying, okay, everybody except for that number. So negative infinity to 7 union 7 to infinity would be our domain. For our x-intercepts, we let the y be 0. In other words, we let the f of x be 0. Now, just like on number 17, the previous problem, there's no way this is ever going to equal 0 because the top of the fraction is not 0. Another way to think about it is if you multiply by x minus 7 squared and x minus 7 squared, well, 0 times anything is 0, and you end up with 0 equals 5, which makes no sense. So because there's no solution to this equation, that implies that there are no x-intercepts. Now for the y-intercepts, instead of letting the y be 0, we're going to let the x be 0. So f of 0 equals 5 over 0 minus 7 squared. Well, 0 take away 7 is just negative 7. And negative 7 times negative 7 is positive 49. So our ordered pair is going to be 0 for the x and 5 over 49 for the y. Let's go put some of these answers in. Okay, so we said from negative infinity all the way up to 7, union 7 to infinity. And then we said that there were no x-intercepts. And we said there is going to be a y-intercept at 0, comma 5 divided by. Okay. All right, so now let's go get all these asymptotes, okay? So let me just take a copy of that, give us some more space here. All right, so remember to finding vertical asymptotes. You factor, you cancel, and you set the denominator equal to 0. Well, there's no factoring and there's no canceling to do on this one. So we're simply going to set the denominator equal to 0. Now we've actually already done this math, right? We square rooted to get x minus 7 equals 0, and then we added the 7 over. So x equals 7 is going to be where our vertical asymptote is. So let's pretend 1, 2, 3, 4, 5, 6, 7. There's our 7. We got our vertical asymptote there. By the way, we have the point 0, comma 549. So that's about like right there as our y-intercept. So we have a couple things so far. All right. Now we want to look and see if we have an oblique. If I were to FOIL this out, by the way, it'd be this. You don't have to FOIL the whole thing out, but you do need to know that the front number is x squared. That way you can compare your x to the 0 to your x to the second. Okay, because the top is not 1 degree higher than the bottom, there is no oblique asymptote. Okay. All right, so let's move on to trying to find or trying to figure out if we have a horizontal. Well, again, we have the big bottom case, just like on number 17, right? We have a bigger bottom. 2 is bigger than 0. So that's going to imply y equals 0 is going to be our horizontal asymptote. So I think we have an idea of what's going on here. This should look something like this. Okay. Now we just have to figure out over on whether we're up here or whether we're down here. So a good number to plug in would be the number 8, since the asymptote's at 7. If we plug an 8 into the original function, right? we get 1 squared. Well, 1 times 1 is just 1, and 5 divided by 1 is 5. So we would be positive, right? We'd be at like 8, 5. Let's just pretend it's, I don't know, like right here, okay? And so we're going to end up being like this. We know for sure we're not down here because these are where the negative numbers are, okay? So it looks like we'll have a graph looking something like that. Let's go put this in and pick it out of a lineup, okay? So we said x equals 7 was going to be our vertical. We said that there was no, we're on horizontal. We said y equals 0 is the horizontal. And then we said there was no oblique. Remember, if you have a horizontal, you cannot have an oblique. They are exclusive, mutually exclusive. Okay. So then let's go see if we can find it. So it looks like all of them have their asymptote at 7. So we definitely had to have it right that they're both positive and up here, right? Nope. I want to point out to you guys something to where it'll be really easy to see right away which one of these it is. This graph is the only one that has both branches being above the x-axis. In other words, both branches are positive, right? They're y values, okay? How did we know that it has to be this one where everybody's above the x-axis and not one of these others? If you go back to the original function, squaring always turns things positive, right? If you have a positive and you square it, you're positive. If you have a negative and you square it, you're positive. So that implies that this whole function has to be above the x-axis because it can never be negative no matter what we plug in. So if you can spot that, oh, okay, 5 is positive and for sure the bottom's positive because I'm squaring. Okay, well then it has to be D without us doing a lot of work. It's a really cool trick to make it a little bit easier to pick these out of a lineup or a multiple choice test. All right, let's go and check it. We are looking good. All right, you guys, hopefully this helps you out with number 18. Thanks for joining me.